Okay, sir. So I will request JL sir to kindly take the questions after the presentation, and I will request all participants to put their questions in the chat box so that JL Singh sir can go through them and kind of volley them after my part is over, just to streamline our presentation a little bit. This presentation is triggered by Sanjay Mukherjee, sir. I'm not really sure whether he's there in this meeting or not.
Is there? Sanjay Mukherjee is there.
Okay, so he was the, let's say, prime instigator for the presentation. And what I have tried to do is I have tried to cover a little bit of history and what is the relevance of water in railways context, and then come over to the current. This will be the general flow of the presentation, and I start with historic perspective. So basically, we'll have to understand the world dynamics, the earlier pre-colonial era of India, if you want to really understand how railways came in India. So this is a 17th and 18th century map of trade routes, which were predominantly by the British, the Dutch, and the Spanish. So these are based on ship log of that period, and you can see the most of the transaction was happening in the Atlantic area. But yes, um, India was a major colony for the British, as well as it was a good source for raw material and exotics like silk and spices and other things. So these companies, in fact, if you know the world's first exchange was formed in 1602 in Amsterdam. In Britain, London Stock came up in 1801, and Madrid Stock Exchange came up in 1831. So even though we normally tend to think that the colonialism was primarily by the countries, but the corporations of that time played a very significant role. And they were primarily moving through water by shipping connections to their respective colonies. So in case of India, East India Company was the major player. All of us know what is East India Company. And of course, Dutch East India Company was also having a small presence. French had the presence, but French didn't had a major company as such during the part when they came to India. So let's go to where all it started, where the railways started, which is basically in UK. So even before,
before the announcement of ceasefire and after the
I
announcement
think
of
I
ceasefire.
think GK, whoever it is, yeah, thanks for muting. So even before the railway started in England, in Great Britain, it was having a good system of canals. Basically, this is again somewhat connected to um, imperialism in the sense that whatever raw material and thus were coming from various parts of the world, they had to be brought in inland. So you had a network of canal systems in UK, and when actually railways started coming up, these canals were also actually basically managed and maintained and even created by companies. They were not state-owned; they were by individual companies who used to raise capital for making these and then exploit them. So when railways started coming, then there was a competition, and the canals started feeling threatened. And there was, where the capital will flow to the canals or railways. These kind of discussions were happening, and canal, since it was a already entrenched transportation sector, they kind of prevailed in UK, and they insisted that the railways will not affect any canal which is navigable. So in Britain, the all the water regimes were kind of conveniently shared by both railways as well as canals. When the British came to India, India already had a good waterway system in the sense that it was tough. but it had a very extensive waterway system. Especially, I'll be mainly focusing on the northern part of India and especially the eastern part of the India, because these were the places where primarily first important railway structures were made by the British. And also these where a good amount of waterways were available already. Ganges, of course, had the waterway, and there used to be earlier sailboats and barges which were traveling in this. And the GT road between Delhi and Kolkata, it was kind of revamped during this time, and 1848 it came into being. But 1848 is pre-automobile era, so you didn't had any trans motor vehicles like that. So you had, either the horseback or the bullock cart, those kind of transportation mediums were there. Interestingly, uh, steam locomotives came much, much afterwards, but the steamboats in India, they were already there much before the railways came in. And in Ganges waterways, basically steamers can carry up to 60 tons of load with a speed of 6 miles per hour. And there was a water connectivity between Calcutta and Allahabad. And even with a steamer, it used to take almost 24 days for traveling between Calcutta and Allahabad. So we saw that ultimately the whole objective of railways was to connect the ports of Bombay, to start with Calcutta, Bombay, Madras, Karachi to UK. And there are many reasons given for this. Of course, number one reason was to give a return to the companies which were making these railways. So you had this guaranteed scheme where a guaranteed rate of return was kind of ensured by the state, by the government, and that was the number one objective of going for this track. And of course, uh, for railway engineers and engineers per se in the UK, it was a great kind of training ground. And all the engineering expertise, they got a kind of free hand to try out in India. It was, of course, to connect the interiors, to bring out the raw material to the ports and bring in the material from UK back to India. In fact, all the railway stuff came from UK only. Of course, the steel works were coming, the rails, the bridges, even the rolling stock was coming from UK. Interestingly, some kind of confusion between this. But initially, even the wooden sleepers also came from UK, because in India, enough number of sleepers were not available because of different reasons, and main reason was the sleeper cost in India was much more.
Please carry on.
So we are back to 1909, I think. Can you see the screen?
Yes, we can see the screen.
Okay, so what I was basically telling was that Britishers made these railroads or trains, tracks, railways in India as an investment for their companies, then to take out the raw material from India as well as bring in the finished material. What I was telling was, even for construction of railways, most of the stuff came from UK. Even the sleepers also came from UK. So this was the condition during the uh, just before the advent of railways. We were basically railways were the inland connectivity for the different companies which were kind of exploiting Indian resources. Well, it was all ending up in London. This is the London port, and of course. So coming to beginning of the railways in India, we all know that 16th April 1890. Oh, I'm sorry. I put 1953. It should be 1853. The first train ran between Bombay and Thane. But during this time, two companies were preeminent: the East Indian Railways as well as the GIPR. The race was won by GIPR, but there is an interesting water connect to how this race was lost by East Indian Railways. The rail enthusiasts will know about it. That first train ran on 16th April between Mumbai and Thane. But actually, the first train of EIR could run only in 1854, about almost more than 1 year afterwards, 1.5 years afterwards, because the ship which was carrying coaches for the East Indian Railway, it sank at Sandheads near Diamond Harbor. So it was almost there, but it sank. So they decided to make the carriages. They'll build the carriages for the train locally in Kolkata, but somehow luck was not in their favor. What happened? Their locomotive, it got misdirected to Australia because of a clerical error, and it reached to Kolkata only in 1854 aboard a ship called Kid Gear. So, because of a clerical error, this happened, and somehow EIR lost the race of starting the first train service in India. This is a picture which I took from NRM, National Rail Museum archives. It is a loco being unloaded from the ship, steamship. Of course, it is not the one which we are talking about. This is a BBCI locomotive being unloaded from the ship. Another water connection was there that earlier, basically, air conditioning systems were not there. So either ice slabs were put in the air conditioned coaches for cooling, or this system was there where the ice was put on the top and then cool air was input from that side. Now, let's talk about the little bit technical part of it, how water and track interact. Um, if you see, the first railway was East Indian Railways. They were trying to lay the track. So I'll be taking example from east side of the country around Kolkata, East India Railways and East Bengal Railways. So Howrah station, there is an interesting thing. In 1850s, when the track was being laid, this is a current satellite image. Howrah was nothing like this. Almost nothing was there on the west bank of Hooghly. Kolkata was on the east bank of Hooghly. But bridging Hooghly was extremely difficult. So that is why they put a ferry service. That ferry service is even now, initially it was a steam ferry service to connect Calcutta to Howrah. Station was made this side because alternate place where they could have jumped the Hooghly, bridge the Hooghly was near Paltaghat, near Barakpur. And there also the river was 710 yards wide. And during a normal floods, the depth used to be 45 feet. But more importantly, the riverbed was very soft alluvium, and they could not even fathom what was the depth of the river. So making any kind of bridge there was not feasible. They estimated that it will take minimum 450,000 pounds sterling and 3 years to complete. That was too much of a time. Whereas at that time the cost of making railway line was 1,500 rupees per mile. Sorry, pound sterling in mile. Also in 1849-50, it was a year when financial markets were down. The government was in not in having good revenue also. So that's why it was decided that Howrah station will be made only on the Howrah side. It will the rail track will not connect to the Calcutta side. In fact, the Howrah Bridge is made only in 1943. And interesting thing is, as it was that time difficult to make any kind of piers in the river, it's a full cantilever kind of bridge, one of its kind in the world at that time. There is another interesting thing that in many places, the connectivity between two rail tracks on two sides of rivers was not possible. So they introduced ferry services. This picture is taken at Mahindru Ghat in Patna, and their very nice arrangement was there between the south side of Ganges and north side of Ganges. Two rail systems were there, and the passengers were transported by steam ferries. And here, the in the ferry also the classes of railways were replicated. So all the passengers who belong to, the first class and all, they will go to the first class cabins of the ferry, and second class, third class, like that, they will be transported. There is also one very interesting example which I could dig out of North Bengal State Railway, where even the wagons were transported by ferry from this side of the river to another side for connectivity, train connectivity. I could get a wonderful paper by Iftikhar Iqbal. He has written in International Asian Forum. He did a study of railways and water regime of East Bengal Delta. So when I talk about what was the impact of railways on water, I'll be taking help of this. This is readily available, and I can share it also. So basically, East Bengal Railway, when it came up, that time you can understand the investment was being made by incorporated companies, and they were very much into cost cutting and all, and they were a bit adventurous also, unlike in case of uh, UK. Here what happened, there was no private basically investment or private ownership of the waterways, and the railways were giving a full hand, whatever way they want. There was no concept of navigable or non-navigable water ways. So, in fact, the advent of railways in East Bengal Railway resulted in killing of many waterways which were there. Not only that, uh, they were specifically given, the canal officers were given authority that they can close it for public purposes. Even diversion of river was also allowed. So what, for railways, in a way, waterways and even river were kind of compromised, and diversion was happening. In fact, if you look at this map, this is a map which I got. It's a replica of old map in 1950 made by US Army. So here you can see this is the alignment of from Rajshahi. This is the alignment. Of course, all this area is in West Bengal now. So this whole area is, it is completely made on embankment. So between Rajshahi, after some time, this embankment starts, and it kind of almost throttles up to Sirajganj. It is going. So this side, between these two rivers, it has almost kind of captured and made a huge dam kind of thing, because of which this back end area was totally spoiled. And here I also try to juxtapose the current satellite image of this area, where Padma River, actually Ganges is called Padma in Bangladesh. So Padma River, you can see it is kind of restricted because of this track and one bridge, which is Harding Bridge, which came up here near Rupur. So this is the current satellite image, and if we try to juxtapose with the old map, you can see alignment of Ganges has changed so much. This Hardin Bridge also, besides the embankments, the bridge construction itself created lots of problems, and it changed the course of river. And in fact, this led to floods in back end all the way up to Murshidabad. It was almost 35 kilometers away from this place. So this is an example of another bridge I am given. Normally, when you put a bridge, you have to put these piers. The wells are sunk, and then the piers are built upon that, and then you can see a steel girder being moved on two barges to fit into this. This is actual photo of Harding Bridge in Bangladesh, current photo. It is this bridge is still there, and you can see behind there is a new road bridge. Now, how these kind of structures affect water, even civil engineers, they have not been able to understand. A river has, in a way, mind of its own. I think the best way how river kind of tackles obstructions in its flow has been studied by an Austrian naturalist. called Victor Schauberger. There's a beautiful book called Living Water, which talks about his philosophy and his observations and how a particular stream or a river will behave. So if you go through that, you will understand that it is not just very streamlined kind of flow as civil engineers will love to envisage, but this case also Padma River has changed course, also moving almost 1 kilometer here because of creation of this bridge. So another thing, because of these embankments and to cost cut, they had not made bridges as many as they were required. So water took a long time to escape through culverts and bridges which were made, which were very few in number. Ultimately, all this resulted in destruction of waterways, flooding in the area, which resulted in destruction of crop, of course, which again have a vicious effect. It created famine and issues of public health. I have not discussed, there are many recorded evidence where the creation of during construction of railways also, because of stagnation of water and other things, many diseases, waterborne diseases were caused, and they resulted in thousands and thousands of deaths of the people who were the labor and all who were involved in uh, making of the railways. Coming to the current era, actually, these kind of things we don't see much because uh, now our civil engineers, they make sure that proper drainage and everything is there, even in the areas where there is going to be a large amount of flow of water and where the rivers are kind of meandering, which is very much there in the northern and western part, sorry, northern and the eastern parts of the country. Rivers down south are a bit more, you can say, disciplined. They don't meander around so much. So things are much easier. Overall, the construction methodology post independence has been more responsible in a way. Uh, I will give you another example in which it is a current example where you see how indirect impact of railways on water is there. This is a Hubli-Ankola new line under construction. This was inaugurated in 1998 by then Prime Minister Mr. Vajpayee. Even now, it has not gone ahead because of various PILs, because of NGOs and other people who are concerned with the environmental destruction. Basically, this alignment cuts through the Western Ghats. On the face of it, it looks like it is cutting through the Western Ghats, so it is not obstructing any the large watersheds. It is not impacting, which are basically from this side to east side and from the Western Ghat to the western side. However, there are water bodies which will be impacted, but more important is what is called old growth forest will be deeply impacted, and more than a lakh trees are supposed to be cut by this. Now, it is going to have an impact. Ultimately, it will result in water crisis. It can lead to desertification in Western Ghats, and there are petitions for stopping this. A very interesting thing is that um, there is another way in which water plays a typical role in with respect to railway, especially destructive role. We have instances of a track being washed out by water, but we also know that there are sometimes landslides. This is an actual picture which I took in Bangalore Salem section, where in a cutting the hillside has crashed down onto a train which was passing at that exact moment. Luckily, no casualties were there. So all the landslides are invariably water phenomena. No landslide you'll have when it is absolutely summers and dry season. So how water will impact alignment of cutting? We really till now there we have not been able to find out any technology which can predict where landslides is going to happen. So this I learned the hard way because in 98, 99, when the Konkan Railway was just starting, I was in charge for diesel locomotive shed at Ernakulam, which is basically feeding Konkan Railway. And almost every week, one landslide will be there, and either my loco will get stuck up or the train will get stuck up. Sometimes the locos used to get damaged also. So there also, it were landslide issues, but basically triggered by water. Uh, re it is not that we get to understand water in totality. Recently, what happened in a new line which is being constructed in Southwestern Railway domain between Puducherry and Bagalkot. Here there is a station called Lokapura. So this is basically a section which joins Miraj to Bagalkot, and this is a new line being constructed, and there is a station called Lokapura. After the station, everything was almost constructed. Suddenly, due to rain, the station got totally inundated. So whatever structure they had made to take care of rains, it was overwhelmed, and they had to redesign the culverts and other things near the station. And now this station is all right. So even in current scenario, also we have our railway system impacting water, as well as water also impacting our railway systems. We do get to know about rather infamous road under bridges, or LHS, low height subways, getting inundated with water. Here also, what is happening is because the formation itself acts like a barrier, and the water, not only it acts as a barrier, it acts as a like a routing mechanism or a collection mechanism for the storm water. So until unless it is designed in a very meticulous manner, these kind of things will happen. And in this case, actually, railways didn't doesn't get impacted, but the roadways, the road traffic does get impacted. Another thing is that we are seeing extreme weather phenomena are becoming almost the norm. If you see total average rainfall of a particular area, it is getting discharged within few days in particular months. So now, probably what railway structures were made earlier, they will not kind of be okay for the current climate situation where things are changing. So either we'll be kind of forced to revise our new construction norms, or otherwise we'll be kind of forced to do the repairs as and when water impacts the railway system. It is not that that railways always, water always, the railways always impacts water in a negative sense. Sometimes track creates water bodies also. I would like to have a flashback. This is a particular section between Lucknow, Sultanpur. This is my village where I was born actually. It's near GT Road. It's called Chandroli. There is a station also, CDRL station is there. So I recall in our village, there was a level crossing gate, and this next to LC gate, it was on an embankment. So on the four side of it, there were four ponds. So these ponds are actually creation of railways. When the track passed and whenever track was being made there, the for embankment, some amount of earth was excavated from nearby areas also. So this in turn created ponds, and these ponds are now actually very, very kind of vital for the village. They create, they are like part of the you can say drainage system of the village, as well as they act like some in some manner to save to act as a sewage treatment system for the village. Railways, many places, not track has created the ponds, but many places the siting of the railway facilities are at the place where ponds are there. This is a picture I took in Bela recently, where our railway factory is there. There two large water bodies are there. In fact, if you look at satellite image, it looks as if this whole facility is in a lake. And I do recall in 2008, 7, 8, when this facility was being made, there was a large amount of landfill which was required. Otherwise, this is very close to Ganges floodplains. So this is one of the water bodies, and this is still another water body, still bigger water body, which is there in Bela Railway Factory. Of course, in railway, we have a wonderful lake called Devargudhyal Lake, which is in near Hubli. Now, this has a very interesting history. Even though it is a railway property, and the water of this lake is being used for Hubli railway township as well as workshop and station area. This particular lake is a man-made lake, and it was created as part of a famine relief in 1907. So, but now it helps in giving water for railway facilities. This is again recently I went to Lilua workshop, and there I noticed that Lilua workshop is also having two large water bodies. They also are man-made. Basically, they were made to one thing is they were made to um, kind of get the land from the low-lying area for making the Lilua workshop, and they also became a very important source of supply of water to Lilua workshop. This is a much smaller example. Here you see in Southwestern Railway in Banaswadi car shed, a small pond was made. This is again, this besides this water was not being used by the car shed obviously, but it helps in recharge of the water in water of Bangalore. Again, in Bangalore itself, you have Indian Railways Institute of Disaster Management, IRIDEM, where the site itself is having a large pond which is used for training as well as it is for recharge also. These are the ponds what we created in RWF, and this is a pond. Of course, it's not having water as of now, but this pond is in Mysore near the railway Ashokpuram workshop. Water, besides being, affecting the track, another thing, water is playing very important role in railway system per se. If you see, the whole genesis of railways is with steam engines and steam locomotives, and steam locomotives cannot run without water. They eat coal and drink water, and that's how they produce their power. And we normally, what happens, when we talk about railways, we are normally fixated around the locomotives, the bridges and buildings, these kind of infrastructure. But somehow, the history of water in railways, especially the waterworks, which will have these huge water columns for feeding water to these locomotives, steam locomotives, has not been preserved, and it's not recorded also. These are the mighty WP locomotives, the main passenger steam locomotives of Indian Railways. And if you see here, water column is there. But to provide so much of water, we had water infrastructure in terms of these steel tanks, steel body tanks on steel structures, overhead tanks. And a typical wayside station will also have a small steel tank which is connected to the water supply system for locomotives. This is a picture of a lake in ICF. If you look carefully in the background, you have this big steel tank which is pre-independence, and this used to supply. Of course, along with that, you can see the new tanks. So some of the railway facility were having either the river, but ultimately from river also we used to have jack wells from which the water will be brought to the reservoirs. From the reservoirs, it will go to the overhead tanks and then it will be used. Of course, in some places, open wells also played an important role. This, of course, is an example from Raipur workshop in Chhattisgarh. But these wells were not only in workshops. Workshop, it was required because in workshop you used to maintain steam locomotives for which water will be required. But even big wells were made near railway station also, which used to cater to the requirement of steam locomotives. This is a very interesting steam tank plus watering column. This is not in India. This is somewhere in Britain, but it was a very interesting picture, so I took it. It's a two-in-one kind of a structure. I try to figure out how much water, what is the water requirement and all. So we have our steam loco Bible by written somebody called Ratta. So I think most of the people who are railwaymen who are in this talk, they will immediately recognize it. So in this about the boiler feed water consumption, it is written there that a medium-sized boiler evaporates about 31,500 pounds of water per hour. Now this kind of this translates to 14,000 plus liter per hour. And a typical WP loco, broad gauge loco, will have a 25,000 liter tender. Tender is a kind of a part of the locomotive where the water is stored. It's like a carriage is coupled permanently to the locomotive. And these locos, they had a top speed higher, but average running speed was something in 50 and 60 kmph. So you can understand this this water, whatever was there, basically will last only for a run of 40 to 50 kilometers. That's why in railways, during steam era, you had water columns every 30 to 40 kilometers. Not only in traction, this is a photo of Jamalpur workshop long time back. I remember, I think JL sir will kind of confirm it, that Jamalpur workshop, of course, it was doing maintenance of steam locomotives, but the power to Jamalpur workshop was coming from stationary steam engine, which was there in a powerhouse. I have vague memories of seeing that, of course, not in action, but it was still there in when I joined Jamalpur for SCRA in 1989. Unfortunately, what has happened? The steam locos were destroyed in a rampant manner, but some sense prevailed, and some of the steam locos have been preserved. But I have not come across any stationary steam engine which has been preserved in railways. So Jamalpur had a stationary steam engine for generation of power. So and this is actually a picture taken from hills near Jamalpur. It has a very elaborate water system, waterwork system. If you see in far end, this is the sunset which is happening, and the sun is a little bit reflected in Ganges there. Ganges is around 14-15 kilometers from, it is in Munger, a place near Jamalpur. And from there, through pipes, pumping by pumping, water is brought to what is called top reserve, top reservoir on the hills. And then after treatment and all, it is sent to the lower reservoir and to the township as well as the workshop. So the Britishers, they first made canal systems in India, then they made railways. They made very extensive water systems, which were called waterworks, dedicated to railways also. These waterworks are the neglected portion of our heritage, but they played a very significant role. They were the reason why the steam trains used to move. Coming to change in traction, even diesel locomotive has a water component to it because you need cooling water for the engine. So water cooling system is there in the locomotive, diesel locomotive, which is very essential. Without this, actually, no locomotive will work. If water is not there in locomotive, and it will not work. Now coming to the our cousins, traction cousins of electric locos. On the face of it, it looks that there no water is involved in this kind of traction. So it is correct on the face of it, but if you look carefully, oh, this is one recent run which has ruffled the fear of lots of rail enthusiasts, whereas actual electric train was converted to look like a diesel train. It is pretending, but in a way, it is actually telling the real story of electric traction. Because if you see the electricity generation in India, 60% plus generation in India is through fossil fuels, either coal, gas, or diesel. Further, there is another interesting thing. Hydro makes another 12%. So if you see 72% of power generation in India has a water connect, because all thermal power is generated by steam only. So in a way, all electric traction is steam traction. Little aside, water and energy, they are having one very interesting relationship. Water has an energy component because there is six level of um, through which energy requirement through which water ultimately reaches you. One is the energy required to pump the water from the source, and then second is that to transport it to your place, and third is to treat energy is required. Then four is to pump to your houses or place of use. Then again, energy is required to take the water, process the effluent, and then finally to push it somewhere. So tremendous amount of energy is required in it is inherently built into water. But if you see, energy is also having a water footprint. This schematic gives a water footprint of energy, and as it is seen that both for fossil fuel as well as nuclear, there is a huge water footprint because ultimately you are generating power by converting water to steam and running steam turbines. So, in a way, when you are doing energy conservation, you are doing water conservation also. And on the flip side, when you do water conservation, you are doing energy conservation also. Now, let us again come to the use point of water in railways. Are we really a consumer of water? Why can't we be a producer of water? If we look carefully, then there is a chance that we can actually what is nowadays called water positive, we can very easily turn into water positive. Normally, as railwaymen, we don't see water um, railway systems as the water systems. If you see a typical train like this Swarn Jayanti weekly express passing through Shindwani Ghat, I think my friend Apurva has taken this picture. I don't know whether he's participating in this or not. So
He's not there today.
yeah. So a typical train like Swarn Jayanti Express, it carries almost 40,000 liters of water. Normally, we only think about the tank sizes in various class, how many liters and all, but train as a whole is carrying almost 40,000. So it's a just like human beings are, water creatures. Even a train is having a significant amount of water carried inside it. Even in a station context, this is a Yashwantpur railway station in Bangalore. If you look at it, in the year 2023, the total water consumption was almost 2 lakh kiloliters, with a water bill of more than almost 2 crores. And a facility like that has a daily average water consumption of 500 KLD. A good amount of water goes in coach watering. These are the watering hydrant, typical type of water hydrant fitted on a track along the track. But there are tremendous amount of water opportunities which are there. See, each railway track, because of the inherent nature of its construction, it is a like a continuous recharge system. Whenever water falls on it, because of the ballast and the formation, the water goes in. Along with the drains, also they are mostly having lots of vegetation and they are kacha drains, so they will also absorb water. So, especially in a city kind of context, it is very important. Unlike roads, if you see, they are impervious. Whether it is made up of concrete or it is made up of uh, tar, it doesn't allow water to seep in. This is not very unlike railways where all the water which falls on tracks will seep in. Typical coming back to Yashwantpur, it's a huge area. Normally we see only the station part of it, but it's a huge area with the maintenance facilities and yard and everything. Station also, if you see, This is a typical. This is actually M. Visvesvaraya terminal photograph of in Bangalore. If you see these platform shelters, they provide very clean surface for collection of rainwater. Even the concrete aprons which are there at the station, they are very amenable for collection of storm water, runoff storm water. Only thing, this water will need some kind of treatment because of it is falling on the ground, and it will get dirty. The yards are also very good recharge systems. They allow the water to soak. They are not built up, unlike the apron portion of the station. A wayside, typical wayside station is the best recharge structure which can be there, because it slows down the water which falls on it and allows it to percolate in the ground. Another important thing is this is actually a drone picture of railway factory area, and you can see so much so many trees are there. In fact, in 291 acres of RWF, you are having almost 47,000 trees. Each of these trees act as a water recharge. So this is another picture of various wooded areas inside the railway factory. Not only railway facilities, stations and all, even railway colonies can be a good water recharge structure, helping in bringing the underground water levels up. So this is actually Hubli uh, officers colony, and this particular portion is the golf course. There we had done a project where we capitalize on the rainwater which is coming in, put it down into earth, and then extract it through open wells. And this has helped in uh, uh, a kind of augmenting the water, which was primarily being taken by the deep bore wells. Now, deep bore wells and open wells are different aquifers, and in a typical city-like scenario, all the deep aquifers are getting impacted. They are over exploited, whereas water is available on the shallow aquifer. Now, slowly in 70s onwards, this culture of open wells has gone off, even in railways, unfortunately, and we are going more and more for deep bore wells. We need to revive open well culture. In fact, Mr. P.K. Mishra, who's a good historian of railways, he was once mentioning to me that olden times, all new estimate for new stations, they were having the open wells built into the estimate itself. All these wells in three wells, what we put in Hubli, they are having water, you can see. Of course, we created open wells. We revived and created some open wells in railway factory also. We created some water paths and water bodies around them. Some new wells were also created in railway factory. We did rooftop rainwater harvesting. We created something called rainwater mega harvesters, which used to take a set of down pipes from the rooftop, take the water, self-clean it and sediment it, and then the water was directly used for cooling purpose. This is another structure which was created there. It's a sedimentation cum filtration bed, which used to catch the runoff, clean it automatically, and push it into the cooling water system. Of course, railways have gone for water conservation in another manner by provision of what is called coach cleaning, train cleaning machine setup. We are having lots of covered area. So these are very much available for rooftop rainwater harvesting. There's a very nice example again in Southwestern Railway in Mysore, where a coach maintenance facility rooftop was used to create, to recharge a borewell which was nearby. And this helped in bringing up the water in the confined aquifer in Mysore area. This is another example of an open well in Dharwad. This well was very good. It was not being used, but we had another case where an open well in Belgaum area is catering to the station as well as the complete railway colony. This actually it's difficult to make out the open well. It is behind this wall, but this well is very much active, and even now it is catering to the need of station as well as the another thing to reduce the power component of water. Another good experiment was done in SWR where solar pumps were used to push the water from GLR to overhead tanks, thus reducing uh, the you can say the carbon footprint of water. Now I will uh, take another totally different perspective of water and how railways can help in making a city like Bangalore, which is water stressed, to make it a bit water resilient. This part of my talk is dedicated to that. The Bangalore is governed by BBMP, and this is the Bangalore area map. And every year, almost we get news of all kind of water crises and other things in Bangalore. And tankers are denorm in summers, not only outside, even railways also is dependent on tankers. So this is very strange because railway can be a net water positive. This is a Bangalore station, Bangalore City Majestic Station area complex. If you see on the north of it, you are having residential area, which is largely a green area. It has a nice ground also in the center. There is a Kendriya Vidyalaya, there is a hospital, and all other facilities are there. This can be a good rainwater recharge system. And not only we can do rainwater recharge, we can actually extract that water and use it. So by when we do that, we will be putting less load on the city water supply. And whatever per day, let's say 5 lakh liters we generate from these facilities will be available to the city of Bangalore. Even the city station also, with its platform cover and all, can be a good generator of water. Good amount of rainwater, fresh rainwater can be collected from here. In front of station also, you have Bangalore city office complex are there. There also rainwater recharge can be done. In fact, here there is one very interesting thing. At the bottom of this picture, what you see is the bus stand there. Now, this bus stand is actually made by filling up a lake. So we have a very strange phenomena in the Bangalore city area, city station area. In the subway, water oozes out just like that. It is because this whole area is a good catchment area and there is a shallow aquifer here. If we just put some open wells here, the whole area, the Bangalore city majestic complex can become water surplus. Same way, Yashwantpur also maintenance facility and station. We have a nice triangle also there, which can be converted into a water body. So if we take these measures, we can help Bangalore become water resilient. We have satellite goods terminal as well as Concor facility, which can be leveraged to do large scale water recharge. Of course, we have done some good thing also, good water recharge projects also. This is M. Visheshwaraya Terminal Complex, where rooftop collection is done. And it is, through the silt trap and sand filter and all, it is being used. And it is able to generate almost 3 lakh liters of water every day, every rain. Nearby in this campus, in this complex, we have the Banaswadi car shed also, which is basically doing maintenance of local trains, MEMUs. Here, extensive rainwater harvesting has been done, and all rooftop water is being collected. And it is after cleaning, it is being injected, it is being put into the uh, GLR for direct use. This complex also has some 19 injection wells. Injection wells are very interesting water constructs. They are basically collecting the surface runoff, cleaning it, and putting it to the deep aquifer. Of course, for shallow aquifer recharge, we have many these rainwater harvesting pits are there. We are we are going in a big way for water recycling also. This is the water recycling plant at the city station. We have one at Yashwantpur also. So that requirement or at our coaching train maintenance units, the coaching depots, like coach cleaning, train cleaning, and other things are being met with this recycled water itself. The station development which is taking, these are two photos, one of the Kant on the left and the Yashwantpur on the right. These are also going to take care of our rainwater harvesting. Extensive rainwater harvesting is planned in these, so that ultimately these area also should become net zero as far as water is concerned. We are also going for revival of wells which are there. This is a Krishnarajpuram shed. There is a abandoned open well. There is a program to revive this open well as well as create 4 more wells there, so that we exploit the shallow aquifer there and don't put load on the deep aquifer as well as the municipal water supply. Not only the systems in railway systems in a city like Bangalore, they can be generators of water. They also help in flood mitigation. As we had seen, because of the extreme climate events, floods, cities are becoming more and more prone to flood. So, in fact, this is a small example, very small example, where this track on the left, you can hardly see any track, you can only see the dead end. This is again in Banaswadi car shed. So this part of the track was getting flooded. So we created a pond along with that and recharge injection wells along with that. After this inundation of track was removed, and not only it saved the track, we created some new recharge structures. And this whole area is saturated with water. We can very easily get water from open wells here. This is another example where near the Krishnarajpuram shed, quadrupling of track is being done. Now, because of quadrupling, change of the topology of the track and other things, Krishnarajpuram shed was getting flooded. So we have a plan to direct all this water to a newly created pond where this water will go and it will recharge the groundwater. These are the injection bore wells. No, this is one very good example. Actually, not only in the complexes, railway complexes, even the running line also we can do injection borewell recharge. Or if adjacent land is available, we can do even a pond recharge also, and thus kind of recharge our water aquifers, both shallow as well as wide aquifer. In this place, some track work was going on. This is near ITC flyover near Baipanelli. So this was getting flooded. So there we created 2 set of injection well. You can see this is one set of injection well in the foreground. There is another one in the background behind this train. So this injection well now, whatever flood water is there, actually it is taking and pushing it down into the earth. And it is not only recharging, it is also helping in mitigation of flood of this area. So if we can have structures like this along the track, total of almost 30-40 kilometers of minimum track is there through the city of Bangalore. And if we can create these kind of water injection systems along the track, then we can push lots of water into the earth and kind of replenish the aquifers which are getting overexploited in Bangalore. And this is the way it is done. This is a typical injection well. You have a silt trap unit. Then inside you have a unit where the water gets filtered and it gets cleaned. And through this V-wire screen, it is getting in and getting recharged into the aquifer. Normally, we go up to a depth of almost 30 meters. So this is the system map of Bangalore area. And you can see that we have a good amount of track here inside the city. Till now, actually, we had only talked about quantitative aspect of water and how it impacts railways. Railways also impact water quality in a negative manner.
Ajay,
So,
you exceeded your time.
okay, so I'll quickly finish this wind up. So, in fact, Howrah station was supposed to polluting the Hooghly River, and because of which court case was put, and now a treatment plant has been put there. Of course, the bio toilets, I will not take much time in this, but bio toilets are very interesting thing. They can be taken and used in stationary application also. This is actual bio toilet being used in Raipur workshop for the static toilets there. This is a very interesting example where the this Lilua workshop pond is having water coming from the colony area, and it is a kind of self-cleaning. There is a impact on water quality because of solid waste management also. Because of time constraint, I'll not go through this. But all our solid waste, ultimately, when it goes for processing and all, it goes to a landfill somewhere. And there is a big problem of leachate from this, which goes and spoils the water. So the waste segregation and solid waste management becomes a very important part, not only of the waste management, but also of the water quality improvement. Railway has done significant work. These were some examples of Southwestern Railway. Because of paucity of time, I will not take this. I'm just quickly concluding. Railway is having a very robust water policy, which was made in 2017. It is a good kind of guide for railway units to um, go for water conservation and being more water positive. I will just conclude by telling that ultimately water is having one important component, that we have to have conversations around water, and railways, given its large family of 1.2 million employees, as well as moving 23 million people, I think railway can play a very significant role in bringing water to the forefront by its actions also, and by motivating others also. I'll conclude by this couplet by Bashir Badr. अगर फुर्सत मिले पानी की तहरीरों को पढ़ लेना, हर एक दरिया हजारों साल का अफसाना कहता है. So thanks once again. I close with the photograph of my dear friend Apurva. This is a picture which is taken of a train over the bridge. I think this is bridge over Krishna River, if I'm not wrong. So with this, I conclude my part of the talk. And if any questions are there, JL sir, I'll request you to help me with the questions.
Well, thank you very much, Ajay, for giving us a very comprehensive account on the relationship between the railways and water and how the two can, in fact, assist each other. There are a few questions. Abhinav is asking, are the water bodies in CLW natural?
I'll just stop sharing just a moment so that we can have a one-on-one conversation.
The question was, are the water bodies in CLW natural?
As far as I remember, I am aware of CLW is having natural water bodies. Whether any constructed water bodies were also made, I don't have much idea about.
Again, Mr. Anand will probably know the answer to this.
Yeah, Anand sir, if you can help me out with that.
Mr. Anand? If anybody has an answer to that, the water bodies in CLW?
Yeah, CLW had
just 1 minute, sir. Sir, just 1 minute. Many people from my water group are also there. So CLW is basically Chitranjan Loco Works in West Bengal.
There is a small river called the Ajay River, and the railways constructed a dam over it to supply water to the colony and the workshop. Ajay River, not Ajay Singh River.
I'm aware of that, sir. So probably you mean to imply that some man-made water reserves also might be there.
From what I recall, the water bodies in CLW are probably man-made.
Okay.
So Mr. K.S. Gopal asks, could you throw light on water management in railway housing colonies as they will have a wider adoption?
Gopal sir, is he there? I can't see him. But anyway, water management, yeah, he's there. So water management in railway colonies, basically, it is more to do with supply of water and making sure water is available. The colonies per se, you have to understand and see the correct context. The colonies, most of them are pre-independence. You know, the British era colonies are there. So that time there was, and most of the colonies of railways are not in city areas. So that time the concept of city sewerage system was not there. So most of the colonies on the supply side, you have the supplies coming through either the waterworks or the open wells. But on the output side, that is the treatment, used water treatment side, there is not much. Now it is being done. Lots of places sewage treatment plant is being made. Now, one very, very interesting thing is there. Most of like for water treatment, especially sewage water treatment, we talk about separation of human waste and what is called black water and the gray water. In railway colonies, one interesting thing is there by design, it is separated because most of the places you are having the system of septic tanks. That's why the human waste goes separate and the other gray water is separate. So there, in that manner, if but again in railways, ultimately when STP is being made, probably all of these is going to be combined. So it is a good thing that we have not gone that way, and probably we can have a separate, newer design of systems in railways. Gopal sir, I'll take it offline later with you. We can
Right.
discuss it in a bit more detail.
And you should write about it. That should become manual for others, all colonies of all types. Because you seem
Sir.
to have, railways, I think, has done much better job than anybody else I know. Yeah, thank you.
There are two questions by Muni Raval. One is, what were the HQ curves of solar pumps installed using solar energy? I don't understand the question, but maybe you can answer it.
गुरुजी प्रणाम, आप हरदम बाउंसर फेंक देते हो. I will have to do some research and get back to you on that.
Anyway, another question is, injection wells are for disposal and not extraction of water. How did you balance water demands?
Who's asked that question?
Muni Raval.
सर आपका क्वेश्चन क्या है एग्जैक्टली? बेसिकली इंजेक्शन वेल जो है वो डेडिकेटेड इंजेक्शन वेल हैं जिनकी मैंने बात की थी. दे आर डेडिकेटेड इंजेक्शन वेल. दे आर ओनली डूइंग रिचार्ज. दे आर नॉट बीइंग यूज्ड टू एक्सट्रैक्ट वाटर.
So between disposal and demand, how do you balance the equation?
वहां पे इन ट्रू सेंस देर आर टू एस्पेक्ट. आई आंसर योर क्वेश्चन इन टू पार्ट्स. वन थिंग इज भी बैलेंसिंग का तो कोई सवाल ही नहीं उठता इन द सेंस कि द वट एवर अमाउंट ऑफ रिचार्ज वी आर डूइंग, इट इज very less compared to what is being extracted out in the city as a whole. So but this is what I'm saying, these are the possibilities at least कि कुछ concentrated बड़े बड़े स्तर पे हो सकता है. एक तो वो बात है. दूसरा पोर्शन जो है कि जो हमारी डिमांड है, डिमांड साइड मैनेजमेंट जो है, रेलवेज में डिमांड साइड मैनेजमेंट का बहुत ज्यादा स्कोप है क्योंकि चूंकि पानी उपलब्ध है, बहुत आराम से उपलब्ध है, इसलिए लोग एक तरह से तसल्ली से इस्तेमाल करते हैं. इनफैक्ट अगर हमारा जो our what is called the manuals and all, they provide for 200 liters per day per person, which is very high compared to 135, which is the national requirement. And now there are, I think, national building code is trying to bring it down further. और ये इसमें तो एक वो एस्पेक्ट भी है जहाँ पे भी रेलवे में बहुत काम हो सकता है. इसीलिए मेरा जितना एफर्ट है वो अधिकतर एफर्ट रेलवेज के साथ ही फोकस्ड है क्योंकि रेलवे में समझता हूँ कि एज अ सिंगल एंटिटी रेलवे कैन मेक अ ट्रेमेंडस डिफरेंस एज फार एज वाटर इज कंसर्न इन ऑल एस्पेक्ट ऑफ योर वाटर, वेदर इट इज डिमांड साइड और सप्लाई साइड. दोनों जगहों पे बहुत काम करने की जरूरत है. एंड दैट्स व्हाट आई हैव डन. दीज efforts of railways, I have tried to map on the city of Bangalore, Of course, I live in Bangalore, so that is, I mean, vested interest. But apart from that, Bangalore is water stressed, and lots of work is required to be done.
Sir, any explanation for why 200 liters per capita demand?
I could not figure it out. Actually, ये मैनुअल्स हमारे क्या है ना, ये ऑलमोस्ट 100 साल पुराने मैनुअल हैं. तो कभी किसी ने कुछ दिमाग हो सकता है लगाया होगा, उसका कोई मेरे को रीजनिंग नहीं मिला. और रेलवे सिस्टम के साथ है कि अधिकतर चीजें चली आ रही हैं, स्पेशली जो ऑपरेशनल चीजें रेलवे में हैं वो चली आ रही हैं, इवॉल्व हुई हैं, लेकिन बहुत सारा चीजें इवॉल्व नहीं हो पाई हैं. जैसे जो पानी पहले था, पहले पानी के बारे में कोई बात ही नहीं करता था इस तरह की. और पिछले लगभग 20 सालों से धीरे धीरे करके ऑलमोस्ट एक्सपोनेंशियल रेट से हमको समझ में आ रहा है कि पानी का जितना ज्यादा से ज्यादा बात की जाए, जितना ज्यादा से ज्यादा एक्शन लिया जाए, उतना ज्यादा आसान है. तो ये भी एक रिक्वायरमेंट है जिसपे मैं पॉलिसी लेवल पे काम कर रहा हूँ रेलवे बोर्ड से बात करके, कि इवन मैनुअल रिवीजन की जरूरत है, क्योंकि हम कैलकुलेशन भी फिर अपना रिवर्क करें और फिर अपने सिस्टम्स को भी उसी हिसाब से यूज करें. और लोगों को सबसे जरूरी है कि लोगों को सेंसिटाइज करें कि जो हमारी कॉलोनीज में जो ज्यादा वाटर कंजम्पशन हो रहा है, पहले तो उसको भी कम करने की जरूरत है.
Jail, can I ask a question?
Mr. Ravi has asked a question. How steam loco water supply was managed in deserts?
Very interesting question. I'll have to do a little bit research. I can only do a guesswork. Probably, this concept of water trains is not new. It is pretty old. So there, you used to have water tanker trains. Probably these were stationed at a strategic location so that the steam loco will not go thirsty.
I can
That's
add
my
to
guess.
this that in this the drier parts of Rajasthan,
Yes.
water trains were regularly run.
Even in Southwestern Railway, even now, sir, water trains are being run. And now what has happened, just like, the roadways have kind of matured. So most of the water, it doesn't come through train, but it has started coming through the road tankers, even in railways.
Mr. Niranjan Khatri has asked an interesting question. He asks, is Indian Railways taking advantage of posting water conservation messages in multiple languages?
It is being done, but what I feel, it is not being done enough. There is tremendous scope because as I told, we are having 23 million passengers every day. तो अगर कंसिस्टेंटली हम ये करेंगे तो ज्यादा इम्पैक्टफुल होगा. अभी क्या होता है, जैसे टिपिकल रेलवेज में कोई ड्राइव चलती है, वर्ल्ड इन्वायरमेंट डे की ड्राइव चल रही है, स्वच्छता पखवाड़ा की ड्राइव चल रही है, उस समय मैसेजेस आते हैं. और मैं तो ये बोलूंगा कि इस समय वाटर से के मैसेजेस कम है, सॉलिड वेस्ट मैनेजमेंट के थोड़े ज्यादा हैं. और दूसरा चीज एक और जो मैंने साउथ वेस्टर्न रेलवे में व्हाट वन थिंग आई ट्राई टू डू वाज आई रोट टू द एमडी ऑफ आईआरसीटीसी एंड requested him that each water bottle rail near should have a message that bring your own bottle. So that will help in also, reducing dependence on the processed water, as well as it will help in reducing generation of plastic waste also. Of course, it has not been done till now. I'll have to kind of now go after them in little bit more persistent manner.
There are many interesting messages written, many interesting comments. I thought I'll read out one. It is from Sanguni. It says, Ajay talk brought back fond memories of my younger days. Thank you for bringing back those cherished memories. And thank you also for highlighting how water bodies were exploited even during British times. A practice that unfortunately we continue to follow today. In my village, during the good old days, whenever a train stopped, I would see women rushing with pots to collect water. One of my favorite pastimes was watching how they collected hot water from the engine with the help of the train driver. During train journeys, I remember the train halting near a river bridge where water would be filled through a large pipe laid alongside the tracks. Thank you for bringing back those memories.
Yeah, water as well as coal. The steam locos, especially yards, used to be a good, place where to pick coal.
Hello, Jail.
If there are any other comments or
Sir, I think Jan, RK Jain sir wants to ask something.
Yes, Mr. Jain, please go ahead.
Hello, Ajay. I'm RKJ 56 batch. Very, very interesting talk. The railway man talking so much about water and how water is impacting railways and railways are impacting water. I just wanted to, I saw from JL's resume of yours that you are also the Director Sustainability in Mahavir International. What exactly are you doing there? And how did you get into that? And where are you based? Are you based in Delhi, Bangalore, or where?
Sir, I am based in Bangalore, and I was second in my batch to take VRS. First in my batch was Narayan, K. Narayan, who's Delhi based, and he has actually taken technical resignation from railways way back in 2011, and he has joined Container Corporation. After that, he has become MD of one of these small banks, government bank, PSU banks, and he finally quit his active service in 2021, and then he joined the Mahavir International as their chairman. So he's chairman for Mahavir International Delhi. And when he got to know that I'm quitting and I'm quitting to work in the field of water, he kind of onboarded me with Mahavir International Delhi. So Mahavir International Delhi basically is a NGO which is into health sector, primarily into eye health and other healthcare. They have got 3 hospitals in Delhi, and they had just started on a large scale water recharge projects. So now I am taking care of their all water and sustainability projects as one of their directors.
Okay, thank you. Thank you.
JL sir, if no more questions, probably we can wind
I'm
up.
going to say that if there are no more questions, we can end for the day. Thank you very much, Ajay. At least I do not know about the others, but at least I learned a lot.
रावल सर, रावल जी आप कुछ पूछना चाहते हैं?
Just a curiosity. Say, if we take 100-kilometer distance, which is more efficient, steam engine or electric?
I did not raise this question because it was not related to water. But I saw the question. We'll give it.
Sir, it is related to water.
Okay.
It is
Because
related to water.
electricity generation depends on the water availability. And
I
so
think, sir,
does
you have thrown a very important question. What probably a study needs to be, I am not aware, a study needs to be done on water footprint of transportation. What it used to be when steam locomotives were there and what it is now.
No, this electric engine
Ha,
uses electricity.
ji.
But megawatt generation has also water footprint.
That's what I'm saying. That's what I'm saying. So a train moving with a steam engine, what was its water footprint for traction purpose? Exclusively for traction, for running of the train. Traction means running of the train.
Yeah.
And what is the traction footprint of an electric locomotive? That is a very interesting question. I don't think it has been explored. Probably a paper needs to be written on that.
There is one.
Well, then, thank you very much, both Ajay and all the audience. We had a fairly good audience. There are 20 people available even now, which is in fact very good. So anyway, thank you very much. Till the next month.
Thank you.
Thank you, sir.
Okay.
Thanks everybody for joining on a Sunday morning. It's difficult to collect people on Sunday morning.
Thank you, Ajay.